Here we are looking at chapter 7.5, and this is using all your logarithmic properties to solve equations using exponential equations using logarithms. So we're going to take all that stuff we know about logarithms and we can apply that to these questions and make these figure out the answer to these really quickly. Okay, so here's number one. In it, it says solve the following exponential equation. Write your answer as both an exact expression and a decimal approximation rounded 2 decimal places. So we're going to have two answers. One's going to be an exact with the logarithms. Then we're going to take that answer and plug it in our calculator and get a decimal approximation. So when I look at this, previously we had questions like this. And this number was what I call a quote-unquote nice number. For instance, if this number had been 36, then it would have been a much easier question. It's called an elementary exponential equation. Because you could rewrite the 36 as 6 squared. And since they had the same bases, you can set the powers equal. This is what 7.1 I believe was about. We talked about that in class. These are much easier. Well, these questions don't work that way. So what we do then is we rewrite this using logarithms. So I'm just going to rewrite this in logarithmic form. Remember how logs work? Base 6, so I say log base 6 of my answer, equals this. That number goes right here. And then equals the power, x plus 4. Remember, it's this guy to this power equals this. This guy to this power equals this. So I've rewritten it as in logarithmic form. And for someone that doesn't know about logarithms, this is just as confusing as the first guy. Because before logarithms, you didn't have any tools to get the variable out of the exponent. Now you do. You rewrite it as a logarithm. But this right here is a number. We calculated that in the last section. Log base 6 is 635. Well, we can put that in our calculator and actually get a number there. This is just a number, and treat it like it's a number. So let me make sure let's make sure we can get the number here. So I can't do that in my calculator because I don't have a change of base formula or change little doodad here where it would let me put log base 6 in. So I have to do log 635 divide. Oh no, I typed that in wrong. So log of 635 divided by log 6. Remember, it's the change of base formula. We talked about that in the previous video over 7.4. It's just a number, 3.6018. But they don't want an approximation just yet. They want an exact answer. So let's simply just solve for x. What would you do if you're trying to get x by itself? You would subtract 4. Don't let that thing fool you, okay? Just subtract 4 from both sides. Now these two guys don't intermingle, right? You can't just say 635 minus 4 and get one number. It's the two. You have to write the two numbers down. Okay, this is the exact number. Okay, but I can put in log base 6 of 635 just like this and get 3.6018. And I'm going to subtract 4 from it. Minus 4. So my answer, my decimal approximation, approximately negative 0.39816. And it says to 4 decimal places. To 4 decimal places. No, I'm sorry, it says rounded to 2 decimal places. So here's 2 decimal places, and the 8 will make the 9 go up a spot. Well, that makes the 3 go up a spot. So that rounded to 2 decimal places is 0.40, right? If the decimal place 398, that would round to 40, right? 39.8 would round to 40, and that's why I got a 0.40 there. So decimal approximation is negative 0.4. The exact answer is log base 6 of 635 minus 4. Now, on your worksheet, it has something completely different. If you go to Hogs, it does something completely different. And it's much more confusing in my opinion, and I would suggest you just do it this way. It's a lot easier. Hogs takes both of those. So there's number 1. Number 2. So I see 7. I can't rewrite 7 to some power being a 46. 7 squared is 49. It's close, but it won't work. So I'm going to have to use those logarithm properties. So I rewrite this as a logarithm. log base 7 of 46 equals 4 over x. Remember, this guy to this power equals that. Well, now there's a property, there's an idea, a shortcut, and it's basically this. That's true, right? 16 divided by 2 is 8. If you switch out these two numbers, you still get an equality. It's true that 16 divided by 8 is 2, right? If you take a fraction and a whole number and you switch those out, you get an equality. It's a legal move just to switch these two things out. So whenever I see an x in the denominator, whenever I see that, I automatically think of this, and I just switch those two guys out. All right, this is the exact answer. There's the exact answer. The approximation to this, a little bit more difficult. When I type this in my calculator, I have 4 on the top divided by. Now the bottom's going to have a bunch of stuff on here, so I need to start off with the parentheses. Then log of 46 divided by log of 7, and then I need to close up the original parentheses. That's what it needs to look like when I type into my calculator, because I have to use the change of base formula. Oh, it's 46. Typed it wrong. Okay. Log of 46 divided by log of 7. 2.033. And we're rounded to 2 decimal places. So 2 decimal places. I don't care about the whole number. So I'm rounded to this guy right here. So it's 2.03. There's my decimal approximation. Exact answer, decimal approximation. This is the exact answer. This is the decimal approximation. And I'll say it again. Hawks does that completely different. And I just think my way is better. So I go with this way instead of using Hawks' method. Okay. So now I see this guy. But in the previous section, I figured out that if there was a plus in between here, you can put that together with multiplication. So this is, you're able to rewrite this as log base 5 of x minus 5 times x minus 3 equals 3. Right? We can put those together with multiplication. Well, we can rewrite this without the logarithm. 5 to the third power equals x minus 5 times x minus 3. Now, multiply. Let's clean this stuff up. Right? 5 cubed is 125. This would be x squared minus 8x plus 15. Just fold it out. Right? Multiply it all out. We've done these. You've done it. This is solving a quadratic equation. And remember, to solve a quadratic equation, that must be a 0 over here. And when you do have a 0, you can use the quadratic formula. So I'll move this off. 0 equals x squared minus 8x minus 110. So at this point, you're just solving a quadratic equation now. Your A is 1, your B is negative 8, your C is negative 110. So negative B plus minus B squared minus 4AC all over 2A. That's the quadratic formula. Need some more paper here. So I'm going to plug that into my quadratic formula. So negative 8 plus minus, I'm going to go ahead and square my negative 8. Negative 8 squared is 64. 4 times 1, which I'll go ahead and write it just because I can. And then C is negative 110 all over 2 times 1. I'm not going to write 2 times 1. That's ridiculous. All right, because 2 times 1 is just 2. So these, I'm going to clean this up a little bit. Negative 8 is 8 plus minus. If you multiply this all out, I believe you get 504 all over 2. Or you can pause it here and plug that in your calculator and see if you get 504. You should. Now, this is 2 answers in here, right? 2 answers in here. And the directions don't ask for a exact answer anymore. The directions call for a to solve this, round your answer to 4 decimal places. It says you can round. So I'm going to round this off. So we'll take 8, clear all this off. 8 plus square root of 504 divided by 2, 15.22. 497. We'll round it to 4 decimal places. That jumps up the 9, and the 9 knocks up the 4. So it's 15.2250. And you don't have to write that down. So here's one answer. And a second answer would be with a minus in between. Divide that by 2. Negative 7.2250. Now, if we were just solving a quadratic equation, if we were just solving this, you have 2 answers. But remember where this started from. All the way up here. Now, you have to make sure that you do not get a negative number inside those parentheses. You've got to make sure of that. So if I take the 15 number, don't worry about the decimals here because it won't matter in this situation. But if I take 15.2250 and plug it in here, I'm going to get a positive number, right? 15 minus 5 is 10. 10.2250. Over here, if I put 15.2250 in for x minus 3, that's 12.2250. So I'm going to get 2 positive answers, which means I can plug that in my calculator and get a number, and hopefully it comes up to 3 when I plug that in the calculator, and it should. But the problem is with that second answer. As soon as you put a negative number in for x, you're going to get a negative answer inside this inside the parentheses here. That's not good. You can't. It's an imaginary number. So that breaks the whole thing. So you cannot use the negative answer. It's not an answer. You have to test both of these. So your only answer is 15.2250. That's the only answer. Now in the worksheet, it gives you the square root type answer here, but that's the same as this without the minus. They've simplified that radical there. You don't have to simplify anything. You just need to find the decimal approximation for that equation. Okay. So let's try another one like that. Let's jump over here to number 5. So jump over here to number 5. I see a plus in, it's the same question. It says the same directions. Round your answer to 4 decimal places. So I want to multiply these 2 guys together. So I rewrite it. Log base 2 of x minus 3 times x plus 3 equals 4. Well, that's 2 to the 4th power equals this. I'll rewrite it without the log. Let's clean this up a bit. What's 2 to the 4th power? Oh, I think it's 16. Let's just make sure. Yep, 16. 2 to the 4th is 16. And we multiply this up, you get x squared, positive 3x, negative 3x cancels, negative 9. That's interesting. So I want to get a 0 here. Actually, there's no middle term. Oh, let's do this exactly like we did the last one. Okay, you can use a quadratic formula here. Your a value is 1, your b value is 0, your c value is negative 25. You can do that, but let me show you a trick. There is no x value, there's just an x squared. If there's just an x squared there, then all you have to do is solve for x. There's no middle term to throw things off. So I'm just going to add 9 to both sides and then take a square root. So x equals, remember, it's plus or minus. Square root of 25 is 5. Not 0.5, but 5. Positive 5 and a negative 5. But remember, check your work. If you plug a 5 in here, you'll get a positive. You plug a 5 in here, you'll get a positive 8 and a positive 2. That's good. You can do that. 5 checks out. What about negative 5? Right, because it's plus minus. What about negative 5? Ah, it screws that up. Oh, it screws this one up too. Negative 8 here and a negative 2 here. Can't have negatives inside those parentheses. 5 is the only answer. Okay, so there's a couple questions look the same, not too shabby. That one wasn't as bad as the other one. Let me jump back to number 4. Number 4 is like the first couple that we did. So I'm going to rewrite this as a logarithm. Log base 4 of 1143 is equal to negative x plus 2. We're just the directions say just solve the following exponential equation. Write the answer as a decimal approximation. Hey, we don't have to write it as an exact answer. We just need the decimal approximation here. That's what directions say to do. This is a number. That's a number. So let's just solve for x here. Subtract 2. So what's log base 4 of 1143 minus 2 equals negative x. Well, let's just figure out what this number is first before I go changing a bunch of signs. So log 1143 divided by log 4, I get 5.0793. I'm going to subtract 2 from that now, and I get 3.08 equals a negative x. Well, you can't leave it as a negative x, right? So you divide both sides by negative 1, or if it's negative x equals this, then a positive x equals a negative 3.08. That's the way I look at it. Divide both sides by negative 1, change all the signs. However you look at that, your answer is negative 3.08. Now you can come back up here and plug that in and see if that works. 4 to the negative 3.08. That's a negative negative, so it's actually a positive, right? If you put a negative in, it's already got a negative there, and the answer was negative here. Makes it a positive 3.08 plus 2. $11.44, close enough, because we rounded a little bit over. Okay, so we rounded, so it's a little bit over. All right, let's check out number 6. This has e's in it. Well, I think I told you in a previous section that if you want to get rid of an e, you take the natural log of both sides. I think that was in 7.2, I believe. 7.3, somewhere in there. Problem is, I can't take the natural log over here just yet because there's a 2 in the way. It's like it got a bodyguard. But it's just a plain old 2 times. It's 2 times this stuff. So I can undo multiplication with a division. So get rid of its bodyguard by division. Okay, now we take the natural log of both sides. Okay, natural log of e essentially kills each other off. They cancel, and you're left with the power. You're still left with the natural log of 24, and the natural log of 24 is a number. You type in the calculator and get it. And to solve for x, you subtract 12. Now, this is what it is. You cannot manipulate the numbers this way. Okay, that is the natural log of 24. It is and always will be. But this is a minus 12, right? So that's what you get. This is the exact answer. I'm not for sure if the question calls for the exact. Yeah, it does. It calls for the exact answer and the decimal approximation. But this is really easy to plug in. It's a natural log. You just type in natural log. Natural log's down here. LN's down here. So LN of 24 minus 12, negative 8.82. And I don't have to check anything here because I didn't start with any logs. I started with e to the x. You could take e to the x all day long with anything. So I don't have to check any work. I don't have to check my answers to see if they're negative or positive. And number 7 seems to be like the same question. Let's just try it again. Divide by 3. Is that 39? 117 divided by 3. Yeah, it's 39. So e to the negative 3x plus 7 equals 39. And you remember how we get rid of the e? Take the natural log of both sides, right? So if I take the natural log of both sides, I know that's really sloppy. Oops. Real sloppy. Anyways, it kills off that. Negative 3x plus 7 equals the natural log of 39. Well, that's a number, so you treat it like one. We'll subtract 7, so minus 7 there. And it's negative 3 times x, so let's divide by negative 3. So x is left with natural log of 39 minus 7 over negative 3. We want both. We want this exact answer and decimal approximation. Whoa! So, put the top in first. Natural log of 39 minus 7. Hit enter. Got to do the whole top first, then divide by negative 3. 1.11. Okay, now you can take 1.11 and put it back in here. 3 e is second ln. Let me clear all this off so you can just have that. So 3 e to the negative 3 times 1.11 plus 7 power. So all that's in parentheses like that. I should get 117, which I do. I get close to it. It's not exact because I had to round here. Okay, it's not exact because I had to round. That's 7.5.